Concurrent engineering. Concurrent engineering, commonly known as simultaneous engineering, is a method of designing and developing products in which the different stages run simultaneously or work at the same time concurrently rather than sequentially. Means here all the stages of production or the design etc. they are run parallelly or the concurrently rather than sequentially. Means one after the one the stages will not be performed, instead of that immediately concurrently along with the particular processes other processes are being performed. So concurrent engineering, what is the aim of it? It aims at harmonization between the increase in product quality and the reduction in development times and cost through a structuring of product development that involves a large design team conducting simultaneous and interconnected analysis and synthesis actions. So in relation to all the phases of development, for example, production engineers need not wait until the design work is completed. Instead, they can work in parallel, suggesting changes for cost effective and simpler production methods and steps for efficient design. So a tolerance problem that can be caught before any parts are made in much easier and less expensive to fix the problem that is found during the assembly stage. So problems are identified and solved as early as possible. That means there will be a proper solution for the problem that arises later, and it will be identified earlier and the proper solution can be done. So the foundations of concurrent engineering are frequently represented by several essential principles. So they are highlighting the role of production process planning and its influence on the decisions of the product design process, emphasizing the multidisciplinary dimension of the design team engaged in the product development process, paying greater attention to customer demands and satisfaction, considering the reduction of development time and of time to market as factors of product success and competitiveness. So if I say the overall concurrent engineering means all the processes run parallelly. That means they need not wait for one process to be completed, the next process has to take place. So when the design is going on, the assembly processes, everything will be analyzed and the problems during those processes will be studied and a proper solution will be done. So this is cost effective also, economical also, and also the engineers can find out the faults easily. So this is concurrent engineering. So next let us move to concurrent engineering. Advantages: reduces product design and development time, limits product redesign, thereby it will allow products to reach customers in less time and at less cost. So it will enhance productivity through early discovery of design related problems which can be rectified soon rather than at a later stage in the development process. So the reduction in the time to market helps companies gain advantage over their competitors, facilitates rapid response of fast changing consumer demands, improves product quality through enhanced design and manufacturing, so facilitates teamwork. So there are certain limitations also. So concurrent engineering can be effective if all the design activities are performed in a parallel manner. So if they are not performed parallel manner, it is not effective. So and the decisions making among different groups are also should be integrated. The concept requires effective collaboration and communication among the team members. So it requires effective computer system for the data transfer and organizational integration. A minor mistake in any stage can impact all the stages or team working with the product. So these are the limitations of the concurrent engineering. So next is design for X system. So what is this design for X system? So design for X refers to design for excellence. So this is a new methodical approach in product design. So where design has the ability to strongly influence the product's performance in every phase of the product's life cycle. So the design itself, the design of the product has to influence every stage of the life cycle from design process to production, assembly, etc., the design should be proper. So excellent, that is design for X system. So the word excellence must not be interpreted in terms of performance or quality or reliability or durability alone. So instead depicted in terms of manufacturing, cost, assembly, or any other varying characteristics. So for this reason, the design for excellence DFX is better thought as a design for X. So they have given design for X. Then X, what does it refers? It refers to DFM, design for manufacturability, or DFE, design for assembly, DFC, design for cost, design for logistics, TFL, and so on. So all these DFS techniques or tools have a common aim to integrate the requirement of the technical area X into the conceptual design phase of the product. So some of the common guidelines to be followed during design for manufacturing and assembly are: first one, simplify the design and reduce the number of parts. So because for each part, opportunity for a defective part and an assembly error. So standardize and use common parts and materials. Then design for ease of fabrication. Then design with process capabilities and avoid unneeded surface finish requirements. Mistake proof product design and assembly. Design for parts orientation and handling to minimize non-value added manual effort and ambiguity in orienting the merging parts. So minimize flexible parts such as belts, gaskets, tubing, cables, and wire harness to avoid material handling and assembly to be more difficult and susceptible to damage. Design for ease of assembly. Then design for efficient joining and fastening. So design modular products. Then design for automated production. Design for ease of inspection. Design simple parts with basic features. Design for environment. So other than this, the more details of this you have to refer the textbooks and read them thoroughly. So next is traditional engineering design and the design with the DFX. So firstly, it considers functional requirements. In the design with DFX, considers life cycle requirements. So in the traditional engineering design, addresses other aspects after design phase, other side as early as possible, and iterative in nature in the traditional engineering design. And here it is one time right, heavy usage of tools, and other side heavy usage of systems, computerization of tools. So in traditional engineering design uses CAD tools. Design with DFX depends on knowledge based systems. Traditional responsibility over design, and design with DFX responsibility over whole life cycle. Design solely based on user requirements, production, service, etc. have to adapt to designers' work. Integrated design with involvement of cross-functional teams.